In this video, I want to take a look at doing a visual trace for the selection sort algorithm. So let's take a look at what we have here. We have this graphic. The way this graphic is kind of set up, the way it's meant to be read, is that you have basically your index 0 over here, index n over here. And this is maybe somehow the value, right? So the vertical, right, is value. So this is small number. This is maybe this thing over here, right, is maybe a small number, versus this thing over here is maybe a large number. Something like that. It's kind of meant to be a visual representation of data, right? So you have a bunch of numbers. And so what I want to do in this video, right, is basically I'm going to look at this one. I'm also going to look at another one. I want to show you guys basically how does the data flow as you run the algorithm, right? So we're going to imagine that we're going to look at this, right? It's going to be an animation. We're going to see basically the algorithm as it moves data around. And so hopefully what we see here, and this is random input. We're going to look at a different type in a second. But hopefully what we see is this algorithm basically is looking along, looking for the smallest thing, taking it, and moving it to the front. So let's take a look. So we can see we're walking through the data, and notice it does have to walk through everything, but what it's doing is it's basically kind of making a mental note of what is the smallest thing, and then moving it forward. So that animation is super fast. I'll play it again so I can talk about it more. So here we go, right? So again, right, scrolling over the whole thing, and it basically has this internal record of what's the smallest. And that smallest thing, right, becomes that dark bar that you see popping forward, right? So the dark bar is basically the things we've already processed. And it does it again and again and again. And a couple things to notice in here. I guess the main thing is basically that it does less work each time. So notice that when you're trying to find the minimum, you only need to find the minimum of the unsorted region. The unsorted region, of course, is kind of the gray part. Okay, so that's one observation. The other observation is that even though we may see the smallest thing early, we can't really stop because we don't really know that it is the smallest one. Right? Visually, I can tell, that element is smaller, so I don't need to go look anywhere else. But I can't, the algorithm can't do that, right? It does need to look at everything, that it has in order to figure out what is the smallest one, right? And then it brings it forward. All right, let me do this one more time. So again, you can see it's looking through everything, right? And somehow, right, the smallest one is the one that's getting, put into its final position there at the front in the dark black. All right, let's take a look at another input. So this is partially sorted. So this will maybe look a little bit different than the other one. Maybe you can think about it for 1 second. How will this look different, or how will this look the same? All right, let's run it. Going through the whole thing, smallest, 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 smallest. It's basically doing exactly the same thing as the previous algorithm. And this should actually make sense, because if you think about the algorithm, it really doesn't have anything like logic in it. There's not a bunch of if statements or anything like that. It basically just does the same thing every time. Now, this is maybe a little unfortunate in this case, because if I look at the data that's partially sorted, what I can see is that the elements I need to move are actually pretty close to where they're going to end up, right? Where should they be? I never have the case where it's like there's one element that's on one side, far right, needs to go to the far left. I never have that. Things just get moved by 1 or 2 elements. And yet this algorithm is still spending all this time to go all through the entire thing, right, and find what exactly is the smallest thing. So this is probably not going to be a very good case for using selection sort. I'm probably going to have to look at another algorithm and try to do a better job with it. All right, so hopefully this visualization gave you guys a little bit of a better idea of how this thing is put together. So yeah. Hopefully these visualizations give you guys a little bit more intuition for how this thing is put together. In a minute, we'll take a look at the actual mathematical properties of this algorithm.